So on this sheet, what we're going to do is we're going to go ahead and compare and contrast a simple event, an independent event, and a dependent event. We'll start off with the formulas, and I'm just getting the formulas off of the notes pages. So looking at our notes, the formula for one event, the probability of A, is the number of ways that A can occur. I'm just copying this right off of my notes page. Divided by the total number of possible outcomes. Total of possible outcomes. So with a simple event, it's one event, which means you'll only have one fraction. So an example here, a bag contains 3 red marbles, 4 green marbles, and 2 black marbles. What is the probability of a red marble being pulled from the bag? So here we're just looking for what's the probability of red. So the probability of red being pulled, how many reds are there? So the number of ways it can occur. There's 3 red marbles. Out of the total, that should say total, the total of possible outcomes, there's 3 plus 4 is 7. Plus 2 more is 9, so there's a 3 out of 9 chance. Converting that to a decimal is 0.33 repeating. We're going to move our decimal 2 places to the right, and that ends up being 33%. So there's a 33% chance that this can occur. On the likelihood scale, here's 0 and here's 1, which is the same thing as 100%. Here's 0.5, so 0.3 would be about right there, so that's unlikely. So it's unlikely that it's going to occur. So this is just a simple event. It's a one event, an independent and a dependent. Now we're going to talk about whether or not it has an effect or doesn't have an effect. So an independent, when the outcome of one event has no effect on the outcome of the other. When the outcome of one event has an effect on the outcome of the other. So remember, if you're a dependent, whether or not your parents move, it has an effect on you. If you're independent and moved out, whether or not your parents move, it has no effect on you. So the formula for independent, again, just straight off of my notes, the probability of A and B and C is equal to the probability of A times the probability of B times the probability of C. And these will all be fractions because these are the fractions right here. Then the probability, the formula for the probability of a dependent event is the probability of A and B is equal to the probability of A, so we'll just start off with the probability of A, times the probability of B after, you do whatever it is needs to be done by taking out the A. So the probability of B, the probability of a dependent is the probability of A times the probability of B after you do whatever it is needs to be done with A. So let's look at these two examples. They're almost identical. It says a bag contains 3 red marbles, 4 green marbles, and 2 black marbles. What is the probability of a red marble being pulled? So in both of them we're going to pull a red marble being pulled from the bag. Now here's where it's different. This left one says that it's going to be replaced and then pulling out a green. The right one says without replacing and then pulling out a green. So this one says replacing, this one says without replacing. So that's where your differences are. With independent, everything has to stay the same. The second person's chances have to be the same as the first. The third has to be the same as the first and second. Where with dependent, the first is different from the second, which is different from the third, which is different from the fourth. So the probability, what is the probability of pulling a red and a green? And again, these are being replaced. And the same thing here, what is the probability of a red and a green? But these are not being replaced. When we first start off, both of the bags look exactly the same. So both of the bags start off the same for the red. How many reds are there? In both cases, we start off with 3 reds out of, there's 3 plus 4 is 7, and 7 plus 2 is 9. So there's a 3 out of 9 chance that we're going to pull a red, just like before here. And at this point we stopped. But on this one now, we're going to go ahead and we're going to put that red marble back. So let's just say you have this bag here. You have 3 reds, you have 4 greens, and you have 2 blacks. Well, you pull out 1 red, but then we're going to put, it's being replaced, we're going to put back 1 red. So you take out a red, but then you put back the red. So we still have this exact same thing here. So when we go to when we go to pull the green one, we're going to multiply by our next fraction. How many greens are there? There's 4 greens out of 9 marbles, because there's still 9, so it's 4 out of 9, because it's exactly the same. So 3 times 4 is 12, 9 times 9 is 81. We'll go ahead and we'll convert that to a decimal into a percent. So 12 divided by 81 is 0.148. We'll move the decimal over twice, and we'll just say that that's a 15% chance. How likely is it on the likelihood scale? Here's 0, here's 1, here's half. So 0.15 would be about right here. It's also unlikely. But here you had a better chance of pulling a red than you would have pulling a red and a green. But let's see what happens here when you don't replace it. So we started off with 3 ninths, because here's your bag here. You have this bag, and you have 3 reds, 2 blues, and 4 greens. So you have, what's the probability of pulling a red? You have 3 reds out of all of these 9. But then you pull out 1 red, you pull out just 1 red, but you don't replace it. It says without replacing it. So you leave this red out, and now what happens is you no longer have 3 reds. Now you only have 2 reds in the bag. So when you go to pull the green, we're going to multiply. There's 4 greens. There's 4 greens in the bag, but there's no longer 8 marbles. Now there's only 2, 3, 4, 5, 6, 7, 8. Now there's only 8 marbles in the bag, because you've pulled 1 red marble out. And just because there were 3 red marbles, we're not pulling out all 3, we're just pulling 1 out. So when we go to multiply this, 3 times 4 is 12. 9 times 8 is 72. And when we divide that, 12 divided by 72 is 0.16 repeating, which is a 17% chance. So we have even, it is a little bit greater of a chance here, but on the likelihood scale, it would probably be about right there. So it's still unlikely. So go ahead and work on the back. The same thing, we just have 3 different, you have simple event, then independent and dependent. So here's a problem, and then the same thing here.